Hello everyone. Today we are going to solve the problems of slope stability by using the Taylor's method, and we are talking about the tension crack with water. So based on these conditions, we will solve the factor of safety. All right. So now first let me list down all the informations that already given in the questions. All right. So we have the R. So already we find out the R from the previous solution. So 17.43. So if you don't know how to find out the R, so you use the basic trigonometry formula to get the R. All right. So then we have the cohesion undrained cohesion. So here you can see the undrained cohesions. All right. So 42 kilopascal. All right, so I write, okay, 42 kilopascal. All right, now we have the angle. All right, so the angle is 16.44 degree. So in this case I want to mention, so in the tension crack empty of water and the tension crack when full of water, so they like we will use the same value for the both case. All right, so we have the area also 17.64 and the distance is 5.86. So let me list down all the informations here. So I write, okay, so theta c equals 67.44. Then we have the area 71.64 square meter, d the distance from centroid 5.86, and we have the YC. All right, so now we have to find out the YC. How we will get the find like the value of YC? All right, so we will get the value of YC. Okay, you can see here. Okay, let me just erase the colors. All right, you see here, this is the 6.7, right? All right, so you remember the value of 6.7 here. Okay, so what I will do, I will just times with the z naught value. All right, so let's say I have the z naught value is 4.42. Okay, so if I add this value, so it will become like this. All right, so let me use the equations. So 6.67 plus 2 times 4 point, I mean the 4.42 depth of tension crack divided by 3. So we have to divide it by 3 and we will get the value 9.64. All right, so we have the YC value also. So now in this case we have to find out the W value, I mean for the water. So we will write 1 over 2 unit weight of water, then the depth of tension square. All right, so I just plug in the value. So I have 9.81 times z naught equal, we have 4.42 square. So if I do the calculations, I will get the value of water 95.87 kilonewton per meter. All right, so now we are going to solve the problem based on the conditions. The conditions is tension crack when full of water. So we already organized all the value in here. So what I do, I just write the formula. So we have the formula, if I mean the safety factor formula, CEU R square theta c divided WD plus PWYC. All right, so we have the undrained cohesions is 42 times, I have the R already, I find out, I told you again how to find out the R. So 17.43 times square times, now we have to convert the degree to radian angle. Okay, we have the angle 1767.44. I just convert into radian. All right, so then WD, so we have the WD is 71.64 times 19 times 5.86 is the distance. So I already write this part plus, so I have the W value equal 95.87 times, okay, we have the YC value is 9.54. All right, and then we have the 180. This is from the equation. So if we want to convert the degree to, okay, degree to radian, so we use this 180. All right, now I will solve these equations and I will get 1.88. okay, so that's mean our slope is safe, because when the slope is more than factor of safety is more than 1, that's mean our slope is safe. Thank you so much.